All right, so as I say, equations. All right, so let's just look at setting up equations. Okay, what we're trying to do with them. Okay. We're going to focus mainly tonight on linear equations. So when we're talking about linear, we've got a letter within it. All right, followed by a number, and we use that equals sign. All right, so really familiar with them now. Okay, we've got a letter in it, and we've got an equal sign. Okay, so we're going to go somewhere tonight where we don't use that equal sign. But a lot of the theory, what we're discussing over the next 10-15 minutes, will be used in it. All right, and then the second type that we work a lot with, especially during factorization and stuff like that, quadratics, when we've got an x squared term. So an equation deals with a letter, or it deals with a variable. Doesn't have to be x. I've just used x there. X is the most common. Okay, it could be m, n, v, whatever you want it to be. Okay, that x term is just somewhere we can put a number. Okay, that letter term is just somewhere we can put a number and allow it to make sense. Okay, so the left-hand side equals the right-hand side. Okay, now that's important. The left-hand side and the right-hand side mean the same thing. Okay. So, linear. When we're moving stuff about, when we're rearranging, all right, when we're transposing, okay. Transposing. That's just moving terms about in the x term or the numbers, whatever that may be. Okay, there's two ways of sort of general teaching. Okay, I've sort of been jumping about, I don't want to confuse you, so typically change side, change sign is something I'd say a lot. All right, a lot of people heard that, a lot of people use that, so change side, change sign. All right, I'll also use a sort of terminology balance equations. Okay, now that goes back to the left-hand side is equal to the right-hand side. If you think about that as a sort of seesaw, whatever we do to the left-hand side, we need to do to the right-hand side to stay consistent with it. Okay, so if we are removing something from the left-hand side, we then have to add it to the right-hand side for it to stay balanced. All right, there's two sort of main ways of teaching that. Now, when we're transposing, I've also said that we carry out our BODMAS sort of process, okay, with the brackets, orders, division, multiplication, add and subtract, all right, but we do it in reverse, okay, so the order in which we transpose okay, follows that BODMAS. Okay, the BODMAS is the way we solve equations. All right, but when we transpose, we do it in reverse. Now, this is looking at how powerful each part of this is, each term is. All right. Okay, so the first thing we want to look for is add and subtracts. Second thing we want to look for is sort of multiplications, divisions. All right. The third thing we're sort of looking for is a sort of square terms. Now we call brackets, root terms, fractions, etc. I'll sort of refer to them as sort of barriers. We need to remove any barriers before we start solving the equation. All right, so the barriers we're going to follow sort of bracket terms or root terms, okay, and any fractions we've got. Okay, so we need to deal with our barriers before we can move anything else. Okay, we always need to or be aware that these barriers sort of exist that might prevent us doing these sort of actions that we want to. All right, so it's not as easy as just looking straight away out for body mass. Okay, but these are the sort of order we want to do it. Okay, but there's going to be barriers involved. Okay, that might draw a whole need to be worth off. All right, that add a wee bit of complication into it. This is a lot of stuff that we've sort of covered, we've touched on, but I just want to reinforce sort of process. All right. You will have questions where you will have to solve for a variable, so solve for x, for instance. Okay, so we have x plus 6, 9. You solve for x, then we're looking for a number which we could substitute in place of that x term for that to be correct. Okay. Now, by transposing that, by moving it about, it allows us to figure that out. So it leaves that x term on the left-hand side. Okay, so we've done that quite a lot. Okay, when we rearrange, when we move things about to find a specific variable on the left-hand side. Okay, and whatever the number is on the right-hand side. So to do that, we can do change side, change sign. Okay, positive in the right, so on the left-hand side, so it becomes negative in the right. Okay, so I'm hoping no one that really issues with that. We substituted the number 3 into here, we would get the right-hand side answer. All right, so that's what we're breaking down, that's what we're working out. Okay, doing all these different equations. Okay, we're just solving that. Multiply term over this side. Okay, so 7 times whatever this x is. Remember, x is just a variable, it could be anything. Okay, moving that across, it's a multiple on the left, comes a divide. Right. So again, if I put the number 4, substituted it in where x is there, I would get the right hand side. So the left hand side equals the right hand side. All right. They throw in a couple of different terms. This is where saying we're looking to do a sort of process here. Okay, so whether you're thinking about it in body mass in reverse, okay, or what I write down, first thing I'm looking for is positive and negative. Second thing, third thing, okay, positive and negatives I want to move first. Okay, leaves a multiple over here. I can't move that multiple, okay, before I move that and subtract. Can't do it. Okay, it won't work. Okay. Doing that sort of order. Again, I can double check this. And there's going to be times in the exam where you can do this. Okay. Especially when it comes to simultaneous equations, which will come on to Thursday or Tuesday. Okay. Okay, so what I mean by that, I mean taking this answer and putting it into this and seeing if it works. All right. So the answer we found out is 7. All right. So I'll substitute that in. and make sure the left-hand side equals the right-hand side. Okay, so 3 times 7 is 21, plus 7 equals. Okay, so the left-hand side that I've worked out to equal the right-hand side. Well, that's nice and simple. Okay, but you can do that. At the end of your question, you can double check by going back to the start and substituting back in. Okay, so where the term x is, we'll just put the number 7 instead. Alright, only do that in the place. Hopefully it's too much. Don't get extra marks or that. Don't get extra brownie points. Okay, but if you're double checking your answers at the end of the exam, go back and try it. Negatives, a lot of people struggled a wee bit with negatives when we're moving these about, especially when it's sort of moving it as a multiple. Okay. Now, that left-hand side stays as is. Okay. What we usually want to happen is to leave a positive sort of variable over the left-hand side. Okay, in this case, sort of x. Okay, it's usually best to have the letters over on the left-hand side. We have done examples in the past where we've left the letter on the right-hand side. Yeah, mathematically correct, it's fine to do. But sort of best practice is leaving the letter on the left-hand side. Okay, now moving that number across, that positive becomes a negative. Now, when we're moving this negative x, sorry, negative 4x, when we're moving this negative 4 to leave the x, okay, so remember what we're trying to do, we're trying to isolate that single variable, okay, so we need to move that negative 4 over. Okay. It's negative 4 times that variable, okay. And negative 4 moves over, but the sign doesn't change. Okay, 16 divided by negative 4. Okay, so that's why the change sign. Some people get mixed up a wee bit. When you're moving it as a multiple, you don't change the sign. Okay, the change sign refers to the multiple in that case, and it goes to a divide. Okay, it doesn't affect that as a negative. That makes sense. Okay, so that stays as a negative, and that whole equation will become a negative answer. Okay, so just be careful with the change sign. Okay, when we have that. Okay, and that becomes important when we're doing the inequalities later on. Okay. Just very quickly, just give these a wee try, just to get your head back into it, all right? Just getting comfortable with essentially negative signs and things like that. Okay. Okay, next one. Any issues? Just give me a shit. Okay, so when we're working through it, we sometimes end up with variables in different sizes, you need to bring them together to collect like terms. Okay, so What we do, how do we deal with that? Again, the question would just be solved for x. Okay, looking at bringing that together, so we're collecting like terms. Now again, usually want the letter term on the left-hand side, okay, the number term, the numerical term on the right-hand side, okay. Leaving that 6x where it is, get rid of the number term. Okay, we're just doing that as a sort of change side, change sign. So what I'm doing to the right, left-hand side is I'm adding 3, and add 3 on the right-hand side as well. Okay. 6x now I want to move this to the external, so come on here. Okay, it's a positive 2x. Now that's a whole thing. Okay, so it's 2 times whatever number x is going to be. Okay, so it's an unknown right now, it's just a variable that we can substitute in there. So I'm taking that whole thing, okay, it's a positive on the right-hand side. We're moving that whole thing over to the other side. Okay, so if x was just the number, say x was the number 5, then that term would just be the number 10. Okay, so it'd be positive 10, and we move that up to 6x minus 10. Okay, so that whole thing is a positive on the right hand side. We move it over here, then it becomes a negative on the left hand side. Okay, so it was 6x minus 2x equals 15 plus 3, which is 18. Okay, so that like terms. Okay, that just simplifies a wee bit. 4x, and then that 4 can go back over to the other side. Once we've collected all the x terms together, give me 18 divided by 4, which is 4. Okay. Don't get confused the fact that that 2 times x has to move across, so is it a multiple or is it a positive or negative? Okay. It works the same, that whole term coming across works the same as if it was just a single numerical term. Okay, so positive over the right hand side, it becomes negative over the left. If I skip away from the screen too quickly, give me a wee shout or hand off now. Give me a wee shout. Okay, doing the same thing. Next. Never mind, apologies. Right, apologies, I've mixed up that question. Just score that out. Copy the x terms from one question and the numbers from the other. So that'll be plus. There you go. Yeah. So that those two operations in the same line, that's fine. Okay, we wouldn't lose any marks for that. We give you negative 2x, collecting the terms together, and give you positive 2. Again, you can double check that by substituting that into that original equation. Okay, so I'll write out that original equation again. Okay, so it works. Okay. Does that mean when we're substituting that back in, we're just making sure that the left-hand side, when we work out all that stuff, when we substitute that number in, it works. All right, the equal sign, the left-hand side has to equal the right-hand side. If you substitute that back in, you end up with negative 19 equals 403. Then something's gone wrong, you're fucking out. And it happens, all right. My notes. Try a few. Okay, equations containing fractions. Again, we've done these. Okay, I just want to recover it, just making sure we're starting the year with it in our mind. Okay. Fraction reminder. When we're doing operations to them. Okay, when we've got a plus or a minus. Okay, we've two fractions that we're adding, subtracting. Okay, we do the kiss and smile. Stem smile. Okay, so we're multiplying, cross multiplying, okay, and then multiplying the denominators, okay, to get the same bottom, okay, same number in the bottom. Okay. Multiply, we just multiply the top, multiply the bottom. Multiplies are the easiest ones for fractions. Okay. Divide, slightly more complicated, you have to flip the second term. Then multiply. Okay. Slightly harder, just remembering, you just need to flip that second term. Okay. To be a reminder as well. Writing something divided by something with using the divide symbol is the exact same as that. All right. Likewise, if we've got we can bring write it in a more simplified sentence and make it make sense. Okay. Especially when we're doing non-calculator stuff, a lot of people were thrown a wee bit when we were using those fractions at the start. All right. When we're transposing fractions as well, okay, and we're throwing in a wee bit of algebra. Remember, we've got a fraction written as that, so a number over a number, okay, and then we've got a term written beside it, okay, in this case that letter x. Remember that x is just something, okay. What that means is I'm multiplying that x by 1 and then dividing it by 5 in separate operations. So that could be written, okay, the number on top could be multiplied by x. Written on that as well. In this case specifically, we don't write that one, so it could be written as x divided by 5. Okay, they all mean the same thing. Now, when we're starting to throw in brackets and things like that, a lot of people don't like that. All right, it's thrown off, put it off a wee bit. we can write that, or you can see that written as or you really want it to. They're all the exact same. Okay, so just seeing it in different formats, sometimes a wee bit off-putting. All right. For instance, you'll never see that in an exam. You'll never see that written out in that format. Some people are more comfortable when they're working something out, that it's all in the same line. Okay, so remember you can do multiples and divides in different orders, so you can, it's easier to see that we can move that out a wee bit and change it. Change the order a wee bit. Okay. When we're solving for x, or solving for the letter term, all right, we need to be sort of comfortable with those rules. All right, that's something we're sort of familiar with. And bring that 5 over, comes a multiple on the left hand side. All right. Up and down. You might have thrown a wee bit if I'd written that as. Right, it looks a wee bit weird, but again, it means the exact same thing. Okay, that 5 can come over, and you're still left with. Yeah, it's just seeing it in different formats sometimes catches you out a wee bit. Solving for x. Okay. This is one of these occasions where we need to remove the variables first. Remember when we're talking about variables. Okay, so barriers to transposition, so barriers to moving things about. Okay, the barriers that I'm talking about, we're looking at brackets, we're looking at root terms, and we're looking at fractions. We need to see these within that and make sure we're considering them. Okay, because we sometimes do that as soon as we can. All right, in this case, we've got a fraction. All right, we've got a term over a number there. All right. So we have to remove that fraction before we can deal with the addition. All right, so we can't move, we cannot move that 5 across like that. Cannot do that. All right. We need to deal with that fraction first and move that across. Okay. Then we deal with addition. Then we deal with multiple to isolate the x. Okay, so it's not always the most obvious about that. Okay. That 4x plus 5/2 should also be written as that's actually a bit more clearer about what you need to do first there. Alright, remove everything that's outside the bracket, and then it means you start tidying up and isolating what's inside the bracket. Alright, so moving that half across, that 2 becomes a multiple over there. Exact same process. Okay, so you're looking for barriers. You're looking for barriers, you need to just have them in the front of your mind when you're rearranging. Okay, when do I need to deal with the barrier? When do I need to deal with the bracket, the root sign, or the fraction? Okay, just that way you go with that. Quite same process, we just did. Okay, so barrier in this case is the bracket. Okay. Go on another type of barrier. Okay. In this case, the barrier we're looking at is the root sign. Okay, but we've got something outside that barrier. We've got this quarter to deal with. We've got this 4. Okay, another way of writing that. Okay, we can write it either way. Okay, so you might see it in either format. Okay, moving that 4 across. Moving that barrier now. It's squared. So by number. Let's solve. 571 and 5 is you do this in the calculator. You wouldn't be asked to do that. Again, there's nothing new here. Just making sure we're comfortable before we move on. Yeah, of course. So they vary. You get a lot of different types of transition. So you get a feel for it when you do past questions, really. So it's hard to say. You go from 2 to 4. But it's a skill you sort of need just in.
Do we know which state or prelims going to be?
Yeah. But I get with that. Is that much?
That's really
No, it'll be so Easter. Alright, so just finish this off, just looking at equations. With 2 fractions. Okay. Again, this is sort of something we've covered, and you know, again, before we move on, just want to make sure you're sort of comfortable with it. Okay. Now, again, we're going back to a sort of kiss smile idea. Oops. We've got 2 fractions. Okay, we want to simplify that, put it in most simplest form. All right, combine them into 1. Okay. So the remainder to do that is cross multiply, and then multiply the bottom terms. Okay, so 2x and 2, x and the 5, remember the sign in the middle, and the 2 terms down the bottom. Okay. It's just tidying that up, collecting like terms, and then solving for x. Okay, when you've got that, okay, it's quite common you see that negative x. Okay, but what we can do to balance that out, we want to leave positive x and that's it. So remember that's just negative 1 times x, alright, and we don't put the 1 in. Okay, essentially we can move that multiple over, we can divide that other side, okay, by that negative 1, and that will give us a positive x over here, so we can move that negative sign over. Alright. I'll just leave this from negative side. Okay. So that's just say that was negative 3x over here. That might be more obvious when we're moving that across and dividing that positive 30 by negative 3. Okay. When you see negative in the letter, there is a numerical value there, we just don't write that one. Okay. Solving for x. Okay, cross multiply again. Here I won't draw it in colour, but we've got 30x. One, 6x. In this case, we can simplify that down at this point if we wanted to. Or
you're like keeping that on the left hand side,
mhm.
right? I know it sounds a bit silly, but could you still just do like the 1 times 18 on the other side, just to keep it in your head the way you've been doing it?
Yep, so I'll move that, I can move that 18 over now. Yeah, or I can you can move it at this point if you want to. Yeah, that's absolutely fine. Okay, I just collected that light there.
Right.
I'll move that over now. 1 times 18. One equals. Remember with big numbers, we can go through the process. What number goes into both of them. Okay. And it simplifies down that. What they could throw at you is something like okay. Now, what's important here is that's a complete term. Okay, so that divide by 4 doesn't take that. That doesn't happen. Okay. That divide by 4 is only for that term. So I can move everything within that pink box over to the other side. Okay, in one swoop. Okay. Treat that just like a term. Because I'm moving everything, okay, because I'm moving everything that's part of that over to the other side, I can take that whole thing and then it just changes this add or subtract sign. Okay. And that just leaves that in the term over there. And then I'm just dealing with fractions as I deal with fractions. 60. That is okay. So if you've got big numbers and you can't immediately see what goes into them, if they're both even like that, just half them. Alright, so 64 over 20 becomes 32 over 10, and then it becomes a wee bit easier. Okay. And then flip both of them again, so I'm just half them until I get a number. So, okay. It's the easiest way to simplify something.
Where did you get 64 from?
32 goes across, it becomes 2 multiplied by 30. Okay, next one, this one, they're still writing that? Yeah, sorry. The next one is a past paper question. I've not written down what past paper it's from, but find it there. Okay, but this is a past paper question where they've asked you to solve for x. Okay. Now, what we've done until now is we've moved all our terms about to get all the x terms on the left hand side. What I'm actually going to do here first is solve the fractions on the left hand side and then start tidying it up. Okay, so I'm going to do that. So 7 6s are 42. Do that. Okay, and that means I can get rid of that bottom fraction part. Okay, get rid of one of the barriers. Okay, and then I can start moving that about. Bring that 36 over to our side. That's 15. All right, now it's quite easy to digest. Equations. So you do get these equations, all right? You do get these questions where you resolve that type of setup, all right? Where I was wanting to take that, so we're going to take these rules and we're going to look at something called inequalities. All right? Inequalities in mathematics is when we're not using equal sign essentially. Instead of the equal sign, we're going to use signs like that. So that means greater than. That means the left hand side is greater than the right hand side. Okay. Less than, the left hand side is less than the right hand side. Greater than or equals to. Okay, so that we line underneath the point. Okay, tells me it's greater than or equal to. That's less than. Seen this side before. Doesn't it? Okay, so inequalities, when we've got something that uses one of these symbols. Okay. So something like that. All right. The left hand side is greater than the right hand side. So we need to use a term for x that makes that true. All right. So when we're solving for x with an inequality, is what value of x can you get that would allow that to be true? All right. To solve, we use the exact same process to rearrange. Say negative. Perfectly written. Okay, so to solve inequalities, we use the exact same process that we've been discussing last hour. Okay, no differences except when we need to divide by a negative. Okay, when we have something like that, and we need to remove this negative, it goes over. All right. In that case, that's flips round, and then negative moves. But only when it's a multiple on the left and it's going to the right. Okay. What that tells us, okay, that final answer, that x less than -4, if we put any value that's less than -4, so -4, -5, -6, all the way down, all right, infinity, if we put any of those values in there, then that will work with that. All right, so whereas when we had 4x equals 16, we can only get one answer. All right, there was one value that made that equation fit. The inequality just tells us there's a range of values that allow us to, we can put a range of variables in there. And it was fit. That's all an inequality is. Okay, examples. Solving for x. We're using the exact same process to move stuff about, okay, except when we've got a negative multiple. Okay, so exact same process. Just imagine that was the equal sign. All the x terms come over the left hand side, all the numerical terms over the right. Nothing happens at this stage. Okay, nothing's happening. Exact same. So there's an equal sign, we do the exact same process. Okay. Again, that's a positive multiple. Stays the same. For that equation to work, any number greater than 8, 9, 10, 11, 12 can be substituted in that, and that equation will work. That inequality will work. Okay, that's all that's telling us. Okay, any number greater than 8 can be substituted in there, and it would give us, that would work out. Okay, that sign stays the same. Okay, all the way down. Okay, left hand side is less than or equal to the right hand side. Rearrange using our rules, using the same process. So, tidy it up. And this time, we've got a negative over on the right hand side, but we're moving a positive multiple over, so it is the same. Yeah. Up. When we tidy that up, when we collect like terms, okay, and tidy up the numerical on the right hand side, we're left with negative 3x. So that's a negative multiple. Okay, so we're going to move that negative 3 across. Okay, and when we move that, that switches. That's it. Simple as that. That's the only rule you need to remember for inequalities. Stays as a negative. Mhm.
See, in the exam, see if you've got through it all and you've got the right answer waiting for that sign rightly, would you not get a mark?
Yeah. So how many marks is this worth? So I've got an exam question that's worth 4 marks here. Okay, there's a wee bit more to it. So say this question may be worth 3. This one here would be worth 3. You get a mark for getting that correct, a mark for getting that correct, and you get a mark for getting the.
Okay.
I don't know why I circled that one instead of that one. But I really try. Six x minus 21 is greater than or equal to 10x plus 7. 7x. Okay, so similar to what we just did, okay, let's tidy up that right hand side first. By breaking out that bracket. Alright, see this way. To tidy that up. Alright. Okay, now get all your letter terms over to the left hand side, all the numerical terms over to the right. Okay. Nothing's changing with the direction. Okay, until this point, when I'm taking that -2 over, second the symbol flips. Leaves us.
That's so much more difficult for myself, but on the answer.
What did you do?
I did, so I broke out the bracket, so the
Okay.
second line I got, but then I went right over to the other side right away and done x equals 3x greater than 15 and take away 6 add 19.
Add 19.
Yeah, like bringing that 19 over.
It would be negative. So
I got -10. So basically, -2. I have no idea.
let's hope the markers haven't enough there. All right, I'll go through the second one as well. That bracket out, so -2 minus 6x. All right, so just be careful there with the symbol. All right, tidying that up will give us 9 minus 6x. 6x. Take that 9 over, give us 39 minus 9. That was it. Incidentally, there were 4 marks.
Would you still have got marks, even though?
What did you get?
So I got 5, the only thing I didn't do was like that second line, when you're breaking up the bracket, would I have lost marks for that? You?
Yes.
That's so
Yeah. Would you maybe get 1 out of 4?
That's so bad. Because the holds up marks.
The main point of it is this part. And to get to that part, you need to have an negative there. Alright, so it tends to be, so especially if they're worth at 4 marks. And you've done a couple, you'll see the worst 4 marks,
I think I'll just need
you get a mark for that stage.
Well, at least I don't remember 6 now.
So that stage isn't there, they'll only go worth 3 marks because they're trying to.